So in this video, we are going to see one problem on linear delay model. The question is select gate size X and Y for least delay from A to V. So here they have given the diagram like this. Okay, so here this is my input side. Okay, and this is nothing but a 2-input NAND gate, and this is a 3-input NAND gate. Okay, so the input capacitance we have to find out. Okay, so this is nothing but a NOR gate. Okay, so the output capacitance is 45. So for this path, they're asking me to find the least delay and what is the value of X. Okay. So to find this one, we know the formula D is equal to N into F power 1 by N plus P. So here N represents number of stages. Okay. So here you can see this is my NAND gate, which consists of input and output. So this is the first stage, and this is my second stage, input and output, and this is the third stage, input and output. So N is nothing but 3. Okay. So next P. So P is nothing but path parasitic effort. Okay. So that is nothing but summation of Pi. So here it is ranges from 1 to N. Okay. So usually you have to see that there is nothing but P1 plus P2 plus P3. Okay. So small. Okay. So here P1 is number of inputs. How many number of inputs are there? It is 2. For this one, it is 3. And for this one, it is 2. So total answer is 7. Okay. So now I need to find the value of F. So F is nothing but path effort. So that is equal to GBH. So what is G? G is something but path logical effort. Okay, that is equal to product of I is equal to 1 to N of G. So that is equal to G1 into G2 into G3. Okay. So this is something but we see for an NAND gate, it is for NAND gate it is 4 by 3. Okay, logical effort of NAND gate. So how to find this one? This is a 2-input NAND gate. So if we see the 2-input NAND gate, so AB, so you have to give 1 for NMOS, right? So since these two transistors in series, you have to give the value as 2. Okay, so this is my PMOS. Okay, So for PMOS it is 2. Okay. So this is my output. So if we see the input, the input of A is 4. Okay, this is 4 divided by 3 Cin of A divided by Cin of the inverter. Next is GB represents, that is also 4 by 3. So if you take average, I will get the answer as 4 by 3. Okay. Similarly, if I go for 3 input NAND gate, this becomes 3 and this becomes 2. So we will get G is equal to 5 by 3. Okay. So G1 is 4 by 3 for 2 input NAND gate, and this one is 5 by 3. Okay. Similarly, for 2 input NOR gate, it is 5 by 3. So how, if you see for NOR gate, you have 2 PMOS, it is connected in series, and 2 NMOS connected in parallel. So this is 1 this becomes 4. Okay, so this is AB, this is AB. So if you see, the A value is 5, right? A value is 5. 4 plus 1 5. Okay, divide by 3. Similarly for GB is 5 by 3. So if you take average, it is 5 by 3. So if I solve, I will get this 25 into 4, 100 divided by 27. Okay, so next I need to find the value of B. B is nothing but path branching effect. So that is equal to, so if you see for this path, okay, for this path, so you have to take these 3 values, okay. So x plus x divided by x. So the answer is 3. So for B2, okay, sorry, for B2, okay. So B1 is 1. For this one it is 2. So next for B3 it is y plus y divided by y, that is equal to 2. So this is equal to product of I is equal to 1 to n Bi. So that is equal to B1, B2, B3, that is equal to 1 into 3 into 2, that is 6. Okay. So what is the value of H? H is nothing but path electrical effort, or it is also called as fan out effort. Okay. So this is equal to C out divided by C in. Okay. So C out is nothing but 45. This is Y. Okay. So this is 45 divided by Y. For next one, it is Y divided by X. Okay. For the next, that is for 3 input NAND gate, it is Y divided by X, and for this one, it is X divided by 8. X divided by 8. So the answer is 45 divided by 8. So if what is F? F is equal to G into 45 divided by 8 into 6 into 100 divided by 37. Okay. So this is nothing but T25. Okay. So 395. So we'll get the answer as 125. Okay. So what is D? D is equal to number of stages 3, 125 power 1 by 3 plus E is 7. So you will get 15 plus 7, that is equal to 20. Okay. So next is, Y. I need to find the value of Y. Okay. So this formula I can also write it as N into F cap plus P. Okay. So what is F cap? F cap is nothing but 5. Okay. That is root of, F power 1 by N. Okay. So if I want to find the value of Y, so F power 1 by N, that is equal to G3 into B3 into H3. Okay. G3 into B3 into H3. So what is G3? G3 is 5 by 3. B3 is 2. Okay. H3 is 45 divided by Y. 45 divided by Y. So what is F power 1 by N? That is 5. So if we solve, that is 15 and the Y value is 30. So to consider this one as, you should not consider B3. Okay. So that is the case, that is 15. Okay. So next, I need to find the value of X. Okay. So F power 1 by N, that is equal to G2 into H2. Okay. And you have to take the value of B3. Okay. So this is nothing but 5 by 3 into Y by X, right? Y by X, and B3 is 2. So if you solve, so 5 get cancelled out, and you find X is equal to 2 into 15 divided by 3. That is nothing but 10. So next, let's go for another problem. So the second problem is they given 2 inverter. Okay. The value of input capacitance is 1 and 8. Okay. That is 8. So finding the delay. Okay. So what is D? D is equal to N F power 1 by N plus P. Okay. So here the number of stages is 2. Okay. And the parasitic delay is 1 for 1 inverter. So I have 2 inverters. So that is 2. So what is F? F is equal to GBH. Okay. So here the branch is 1. Okay. And the G value is equal to 1 because for inverter G1 and G2 is 1. Okay. What is H? H is equal to output capacitance divided by input capacitance, that is 64 and 1. Okay. So it is nothing but 64. So if I solve, I will get 2 power 64 into 1 by 2 plus 2. It is nothing but 80. Okay. So next, let's go for another problem. Third one. So instead of 2 inverter, I'm going to add 3 inverters. Okay. So and the values are, on the sizings are 1, 4, 16. Okay. So what is the formula? D is equal to, here the number of stages, 3. So n I am going to change, and parasitic value is 3. Okay, so 3 into 4 plus 3, that is something but 15. So if you see, though I have added one more gate, this is faster compared to this one. Okay, so you have to note the one point. Minimum number of stages is not always fast. So next, let me go for the question is, they are asked you to construct a ring counter with an odd number of inverters. So estimate the frequency of an n-stage ring oscillator. So this is my question. So they have given, this is my circuit diagram. So if you see here, we need to find f value is 1, and we need to find how many stages are there. So if we see, for the first stage, the input is 1, the output is 0, 1, 0. Okay, so it goes to 0. Now it is 1, 0, and 1. So you can see, you should not think it is three inverters are there, since it is since for the first value, the output is going, so the input is 0. Okay, during the next stage only it is coming as 1, 0, 1, 0. So you should not consider this as a 3 inverters. You should consider as a 6 inverters. Six inverters. So n is 6. N is 6. So 6 into 1 of 1 divided by 6 plus 6. Okay. So you will get the answer as 12. Okay. So suppose if I want to implement even number of inverters. Okay. So it is 1, 0, 1. For the next stage also it is 1, 0, 1. So I am having only two stages. So n is 2 here. Okay. So 2 into 1 whole power 1 by 2 plus 2. So the answer is, in other words, for even number of inverters, f is equal to 1 divided by 2n. Okay. So f is equal to 1 divided by 4 for, so delay, inversion of delay is frequency. So f is equal to 1 divided by 4. Okay. So for odd number of inverters, it is nothing but 1 divided by 4n. Okay. And there is nothing but 12. So f is equal to 1 divided by 12 for even odd number of inverters.